Hey guys, this is Mrs. Lyons, and I am going to work through today's homework, front and back of the mixed reaction practice worksheet in your packet. Okay, so what you're being asked to do, being asked to predict the products of synthesis and decomposition and combustion reactions and balance them. Okay, so we want to identify what type of reaction it is. We want to, if we, like, for example, this one, we have to write the reactants and the products. Okay, so this says aluminum oxide decomposes. That should be a big giveaway that this is a decomposition reaction. Okay, so we have to start out by writing aluminum oxide. All right, so if you look at your periodic table, aluminum has a +3 charge, oxygen has a -2. So our formula for aluminum oxide is going to be Al2O3. That's a solid because all ionic compounds are solids. It decomposes, so it's going to decompose into its individual elements. Now notice I just already straight up put a 2 there after oxygen. That's because oxygen, hydrogen, oxygen, bromine, fluorine, iodine, nitrogen, and chlorine. Oxygen is one of the Hober-Finkel 7. It's a diatomic element whenever we see it by itself. Okay, so aluminum is a solid, oxygen is a gas. Okay, now we have to balance this. All right, so if you look at this, Al2O3, so I have 3 oxygen over here, I have 2 over here. So that means I need more oxygen. So I'm just going to write an O2. All right, so now I have 4 oxygen on this side. I have 3 over here. So I need more on this side. So I'm going to write another Al2O3. Now I have 3, 4, 5, 6 oxygen. So now if I add another O2, check it out, 2, 4, 6. Okay, my aluminum, check it out, I have 2, 4 aluminum, only 1 here. So I'm going to go 1, 2, 3 more. Now my equation is balanced. So my coefficients are 1, 2 of these, 1, 2, 4 aluminum, and 3 oxygen O2 molecules. All right. All right. Up next, we have C3H6O. Okay. This is a hydrocarbon reacting with oxygen. So this is going to be a combustion reaction. Nice thing about combustion reactions, the products are always the same: carbon dioxide and water. Okay, oxygen's a gas. I told you you don't have to worry about this compound, solid, liquid, gas. I would have to tell you that. All right, so then we need to balance this. So we've got carbon, hydrogen, oxygen. All right, on this side we have 3 carbon, 6 hydrogen, and 3 oxygen. On this side we have 1. Remember I said 1, 2, 3. Okay, so let's start with the carbon. So I have 3 over here, 1 over here. So if I put a coefficient of a 3 here, now I have 3 carbon. Now I want to keep a tally of my oxygen. Okay, so here I have 6 oxygen on this side and only 1 over here. Okay, so right now I have 7 oxygen. Okay, next hydrogen. I've got 6 hydrogen here, only 2 here. So if I put a coefficient of a 3 here, 3 times 2 gives me 6 hydrogen. All right, let's recount what that did to our oxygen now. A 3 here means we have 3 oxygen. So altogether, I have 9 oxygen. Okay, so 9, I can kind of subtract this 1. So that means I need 8 more oxygen. So if I put a 4 here, okay, 4 times 2 is 8. And then I've got that 1 oxygen over there, gives me 9 oxygen. My equation is balanced. All right. Next up, magnesium reacts with chlorine gas. So we are starting this reaction with magnesium. Reacting with means plus chlorine. So this is a synthesis. Okay. Chlorine is one of the Hober-Finkel 7 diatomic elements. So it gets a 2. All right. Magnesium is a solid. Chlorine is a gas. So when we do a synthesis reaction, these two things are going to combine. and they're going to form a compound made up of magnesium and chlorine. We have to take a minute, look at our periodic tables. The charge on magnesium, is a +2. The charge on chlorine is a -1. So this compound ends up being MgCl2. It's an ionic compound, so it's a solid. All right, check this out. I love these. 1 magnesium on the reactant side, 1 on the product side, 2 chlorine over here, 2 chlorine over here. This is balanced just the way it is. Those are awesome. All right. Number 4, C6H12 plus O2. That is a combustion reaction. We've got a hydrocarbon plus oxygen. All right. Sweet part of these, the products are always the same. So I have CO2 plus H2O, gas, gas, gas. Now it's down to the balancing. So carbon, hydrogen, oxygen. I have 6 carbon, 12 hydrogen, 2 oxygen, and then 1 carbon, 2 hydrogen, 1, 2, 3 oxygen. All right. So we'll start with carbon. I put a 6 in front of CO2. I have 6 carbon. Now let's do our tally of our oxygen. 6 times 2 is 12 over here, 1 over here. So I have 13 oxygen right now. All right, let's balance our hydrogen. We have 12 hydrogen on this side. So if I put a 6 here, 6 times 2 is 12. All right, let's check, see what that does to our oxygen. We have 12. Now we have 6, because this is like a 1. So 1 times 6 is 6. So I have a total of 18 oxygen on my product side. So that means I need to put a 9 here, which now gives me 18 oxygen. My equation is balanced. All right. Up next, K2O. K2O is an ionic compound, so I can just plug in there as a solid. All right. We're starting with 1 reactant. That means that this is a decomposition reaction. All right. So this is just going to, and I'm going to write this down here. K2O decomposes to give us potassium and oxygen. Oxygen is one of the Haber-Finkel 7 diatomic, so it gets a 2. It's a gas. Potassium's a metal, so it's a solid. All right, now let's think about balancing this bad boy. So I have 2 potassium, 1 oxygen. Here I have 2 oxygen. So that means I need 2 of these, right? 2 oxygen, 1, 2 oxygen. Now I have 4 potassium, so I need 1, 2, 3, 4 of those. All right. So now I believe I've got 2 oxygen, 1, 2, 3, 4 potassium, 4 potassium. So when I balance this, I have 2 K2O, 4 K plus 1 O2. All right, last one. Gallium plus fluorine. Gallium is a metal, so it's a solid. Fluorine is a gas. All right. This is 2 elements combining, so that's a synthesis reaction. So if I put gallium and fluorine together, let's look at our periodic table. Gallium forms a +3 ion, fluorine a -1. All right, so I end up with GaF3, a solid. Let's see if I want to balance this. Though this is one of those, I've said you're going to see these when you've got 2 on one side and 3 on the other. You want to get to a least common multiple of 6. All right. So if I think about this, how do I end up with 6 fluorine over here? I need to add a second GaF3. To get 6 fluorine over here, I need to add 2 more F2 molecules. Okay, so now I've got 2, 4, 6 on one side, 3, 6 on the other. I have 2 gallium, so if I add a gallium here, my equation's balanced. So I end up with 2 gallium, 1, 2, 3 fluorine, and 1, 2 gallium, fluoride. Okay, not terrible. Let's flip over to the back. Ooh, these are word equations. These are the ones that are a little challenging. All right. So this says, after eating a delicious school lunch, your stomach begins to break down the food compounds. This is an example of decomposition. Break down, decompose. All right. Over spring break, a group of kids set off some fireworks. The light of the firework reacts with the oxygen in the air, shoots up, and explodes. This is an example of combustion. You decide to do some baking over the weekend. You combine all of your ingredients, pop it in the oven, and after 20 minutes, you have a cake. This is an example of synthesis. When you leave a shovel outside in the wet air, iron reacts with oxygen to create iron 3 oxide. This is an example of iron plus oxygen. That would be a synthesis. Okay. All right, now we have to write some equations. All right, we're going to take these word equations and we're going to turn them into chemical equations. So copper ore, which is copper 2 oxide. Okay, that means copper has a +2 charge, oxygen has a -2 charge. So that's just going to be CuO. It's ionic, so it's a solid. Decomposes, that means we're making something new. Copper, which is a metal, and oxygen gas. Oxygen is one of the Hoover-Finkel 7, so that's going to be O2. It tells us it's a gas. All right. To balance this, let's see, I have 2 oxygen here, only 1 over here. So I'm going to put a 2 here. And then if I put a 2 in front of copper, my equation is balanced. All right. Let's look at this one. Lithium metal. So that's, and let's do this. This is a decomposition reaction. All right, this one, lithium metal, so lithium is a solid, reacts with, when we see reacts with, we do a plus, nitrogen gas. Nitrogen is one of the Hoover-Finkel 7, so N2 tells us it's a gas. In the air to create lithium nitride. So lithium forms a +1 ion, nitrogen, nitride is -3. So our product here is Li3N. That's going to be a solid because it's ionic. All right. Now, can we do this just by inspection? I have 2 nitrogen here. I only have 1 here. So if I put a 2 here, now I have 2 nitrogen. I have 6 lithium. So a 6 here, and my equation is balanced. All right. Butane gas. Ooh, back to organic. Tetra is 4. So this is C4. Decahydride. So that's H10. So let's do this. This is, I keep forgetting. So this lithium plus nitrogen synthesis. C4, H10, that's a hydrocarbon. All right, plus oxygen gas. Produces water and carbon dioxide. I'm going to write this the other way just because I always put carbon dioxide first. And just to kind of show you, it really doesn't matter in compounds which one comes first. This is a combustion reaction. All right, so we have CHO. This is a tricky one, okay, and I'll show you why. So we've got 4 carbon, 10 hydrogen, 2 oxygen, and then 1, 2, 3. All right, so 4 carbon. I would need to put a 4 here to give me 4 carbon. That changes my oxygen. I'm going to make a little note up here. 4 times 2 is 8 plus 1, so I've got 9 oxygen. All right. I have got 10 hydrogen over here, so I need to put a 5 here. Now, this is something you got to remember. Anytime you put an odd number in front of water, and it's just carbon hydrogen on this side, you just should go ahead and double it. Because if you think about it, 5 times 1 is 5. there's no way I can get an odd number of oxygen over here because it's O2. So what I want you to do is whenever you see a odd number in front of water, double it. Okay, so now if I look, I've got 10 times 2, I've got 20 hydrogen. And oxygen, I've got my 8 now plus 10, so I've got a total of 18 right now. But I'm going to put that there. Let's see. But over here, notice I've got 20 hydrogen. Over here, I've only got 10. So now I need to put a 2 here to double that also. All right, so 2 times 4 gives me 8 carbon, 20 hydrogen, and I've still only got 2 oxygen. Okay, so finally, I've got 8 carbon here. If I change this to an 8, now I have 8 carbon, so that's balanced. Now, though, I have 8 times 2 is 16 oxygen and 10 oxygen. So I have 32 oxygen. It's easy. Half of 32 is 16. So I put a 16 there. My equation is 2C4H10 plus 16O2 produces 8 carbon dioxide and 10 water. The last one, gaseous nitrogen trihydride. Tri means 3. So that means we've got NH3, and it's a gas. Creates, so that means our arrows here, nitrogen, which is one of the Haber-Finkel 7. It's a gas. Plus hydrogen gas. So Haber-Finkel 7, hydrogen gas. Look at this. So I've got 2 nitrogen here. I've only got 1 over here, so I'm going to put a 2 here. So I've got 2 NH3, which gives me now 6 hydrogen. So if I put a 3 over here, 3 times 2 gives me 6 hydrogen. And my equation is balanced and my homework is done. I hope that helps. Have a great day. I will see you in class.